Lesson 3.1, Relations and Functions. A relation is any relationship between two values, typically represented by an ordered pair, and defined by an equation, operation, or any other mathematical rule. A function is a special kind of relation. Each x value can only have one y value associated with it. So think of a relation as any relationship you have with any person. You can have relationships with family members, with friends, colleagues, people in your class, and the type of relationship is defined by how you know them. Are they related to you, or is it a friend? Is it somebody you work with? That would be the mathematical rule for the relation. Well, the function is a special kind of relation. So as each x value can only have one y value, the function would be your significant other. You can only have one. Okay. Functions and relations can be expressed in many ways. We can have equations, sets of ordered pairs, graphs, tables, mappings. The x values in the relation are known as the domain, and the y values are known as the range. The domain is the set of input values. So these are the numbers that we put into the equation, and the range is the set of output values. So we plug in x's and we get out y's. The domain is known as a set of independent variables because we can pick any x to plug in. So any value can be selected and input into the equation. The range is a set of dependent variables because the numbers that come out depend on what numbers we put in. In order to represent functions and relations, we have a couple of different methods: sets of ordered pairs, mappings, tables, and graphs, and equations. A set of ordered pairs will look like this. The braces on the end here represent it's a set, and then the parentheses with the two numbers are the ordered pairs. We can have a mapping. The box here at the front is the domain. The box here at the second box is the range. And then arrows indicate which numbers go to which. So 2 and 3 are a pair, negative 1 and 5 are a pair, and 0 and 3 are a pair. Or we can have a table of x, y values, or we can have a graph. If we have the graph, we have the point 2, 3, the point negative 1, 5, and the point 0, 3. How do we know if a relation is a function or not? Well, each value can only be associated with one y value. So every x can only have one y. Now, if we go back really quickly, we'll see that these two x's went to the same y. That's okay. A y can have more than one x. It's just that each x can only have one y. Okay, so function versus a non-function. I have two sets, and no x value can result in more than one y value. So if I say 3 goes to 4, and 5 is 0, 6 is negative 3, 8 is negative 3, and 2 to 2, versus this setup, what we do is we look at all of the domain values. This is our domain, and this is our range. We look at the domain, and we check. We can only have one arrow each. I have 1, 1, 1, 1, 1. This is a function. Here I look at the domain. I have 1, 2 and 2. These have 2 arrows. So this is not a function. Okay, so every x can only have one y associated with it. Using a graph, we can use what's called a vertical line test. If I run a vertical line along the graph, it will only ever touch the graph at one point. So if I move this back and forth again, you can see as we move across the graph, it only ever touched the graph in one point. Whereas if we have non-function and we move a vertical line across, we have more than one point. Where the line is touching the graph. It touches here and here. This is not allowed. Okay, so we're going to determine if these relations are functions. We're going to state the domain and range of each. There's a couple different ways to determine if it's a function or not. First, I'll state the domain. Domain is the set of all of the x's, so I have 1, 4, 2, and -3. And the range, 3, -6, 5, and then there's another 3, but we never list a number more than once. A 3 is just a 3, so it only needs to be listed once. To determine if it's a function or not, we can do a mapping. So we make a box for our domain and a box for our range. I list my domain elements. I list my range elements. And 1 goes to 3, 4 goes to -6, 2 goes to 5, and -3 goes to 3, and then I check the domain box. Looking at my domain box, I see they each have 1 arrow. So this is a function. Looking at our next set of ordered pairs, I'm going to go ahead and list the domain. I have 3, -3, and 2. I don't know what that was there for. And my range is 2, -6, and 0. If I draw my domain box, I have 3, -3, and 2. I draw my range box. I have 2, -6, and 0. I draw my arrows to indicate the relationship. There's 1 arrow each. So it is a function. Okay. Now let's do a hypothetical. What if this set had had positive 3's? Instead of a -3. And then I would have a 3 and a 2. And I would have a 2, a -6, and a 0. 3 would go to 2 and 3 would go to -6. And as soon as that happened, we would be not a function any longer. For graphs, we'll do a vertical line test. I come anywhere along the graph, and you can actually use these coordinate lines. And as soon as I see that one is hitting in 2 places, not a function. Here, if I go and I do my vertical lines, I can see that it never hits more than once. So it is a function. See, 1 time. Now to state the domain and range, do you see how these arrows, this indicates that the line goes on forever. Okay, so it will eventually hit every x and every y. So my domain is all real numbers, and my range is going to also be all real numbers. On this graph, I don't have arrows, so I have ending points here and here. But my x values go from this line all the way over to this line. So my domain is x between -5 and 6. Now my range goes all the way up to 5 this way. And my lowest point of my graph is somewhere right in here. And I'm not sure exactly what number that is. So what I'm going to do is I'm going to say y is between -5, but it doesn't equal -5, and +5, or it does equal +5. And since I don't know that exact number, I can't really list it. I could make an approximation, but it's just as easy to simply put in the less than without the equal to, so we know it doesn't hit -5.